The shielded machine drives where you use the tunnel support, they consist here of segmental lining. So I want to focus on the segment manufacturing and segment storage. Focus then on the support of the TBM with consumables, on the MAC transportation, and want to close with a quick overview on secondary tunneling works. So here you see an overview about generally tunneling sites. Here on a TBM operation where you have either portal area or shaft area, the machine itself, then you have the secondary tunneling works in the tunnel itself, for example, like invert finishing. Then you have the supply of the machine with consumables or with segments or with grout that can be done according to the installed logistical system through MAC cars, locos, with trucks or multi-service vehicles. Then you have the job site installation itself. You can have the segment manufacturing and storage on the machine. You need backfill grout plant. In case that you have a slurry shield operation, you need to have a slurry treatment plant on site, wastewater treatment plant. If you have for a utility job, like for a pipe checking job, for oil, gas, water pipelines, the setup is a bit more compact. You have a small shaft with a checking frame and a small micro-tunneling machine, and you need a small storage area on surface for the pipes that you check through the ground. Then another tunneling site is, for example, for the construction of shafts, where you have the shaft sinking machine itself. You have the shaft is lined, can be lined with invert concrete or in cast concrete, or here with segmental lining, and the setup, this is required for shaft construction. I want to focus here on the segment manufacturing and storage, dependent on your specific project conditions, on the tunnel diameter, tunneling length, the location of the job site. You can have the complete segment manufacturing plant either on site and do manufacturing storage here on site, or if you have a precaster nearby the job site, you can also do the segment manufacture in that existing precast plant off-site. But then you have to look for the logistic chain to supply here the segments in time and not to cause a delay on the tunneling operation works. Generally, these segment manufacturing and storage, there you can have a complete fabrication chain either on site or in a precast plant. You need to have the molds dependent on your tunnel design. You have different number of molds. You have then a complete industrial factory, so to say. You have the mold, you have to do the reinforcement cage, then you have to do the batching with concrete, and the segment mold follows a chain. You go through a heating channel to get the final strength of the required concrete mixture. Then you have to demold the segmental lining to equip it with a sealing frame for water tightness of the segments. Then you have to transport it on a storage yard and until the segments then reach its final strength to be built in as a tunnel support. Here you see a typical mold for the fabrication of a concrete element. This can be These are quite high precision molds for the design here of concrete segments. Then you have along that segment manufacturing plant, you have after the segments pass the heating street, get demolded, you have to equip them or install a sealing frame. You have then further process it to transport it to the storage yard. There's also, that goes with that manufacturing plant, you have all the related equipment with it to supply it here to the storage yard or to load then finally a segment car to deliver the segments to the machine. For the supply of the tunnel boring machine with consumables, you can have two basic systems. You can have either a rail-bound system via train, you have mud cars and a loco, or you can have rubber tire systems that consist either of trucks or so-called multi-service vehicles, dependent on what the contractor has sometimes also available. And these, I have to say that the multi-service vehicles are more and more common in tunneling construction works and more replace the trucks. If we focus on the rail-bound system, with that system, you are not so flexible. You have to follow the rail, so the flexibility is more or less lost. And you have here also, it's limited by gradients up to a maximum of 4%. But you have a high transport capacity, and it's frequently used if you have long tunneling drives. You can have here with these rail-bound systems also combined version for material supply, but you can also use the trains for muck haulage system. So you see here on the left-hand side a typical picture for a long rail tunnel. Here where mucking out was realized here with muck cars, and here a loco. That's a picture of the longest rail tunnel in Switzerland, the Gotthard Base Tunnel, that was in the construction phase. Here it consists, a typical rail-bound system consists here of a loco. You need to bring people in to the tunnel boring machine, so you have the man rider, you have the muck cars that goes in, you have a flat car for some pipes, and a crowd car, and if you have a shielded tunnel boring machine, you have also a special car to deliver the segments in the tunnel. Here, these are the pictures, typical muck car layout, segmental cars. They're designed to take one or two complete rings to transport in the tunnel, man rider, and the crowd car. Here, dependent if you talk about a tunneling operation to start at the tunnel portal area, you have here the possibility just to demold it and to handle the muck on site by just skipping it. If you have a shaft and you have to have hoisting equipment to lift up the muck cars and also to empty the muck cars. So there are different devices and different required systems dependent on the layout of the project. Another system of how to support or to supply the tunnel boring machine are so-called rubber tire systems. These are quite flexible systems. These are diesel-powered vehicles, and you have the advantage of these rubber tire systems is that you can handle steep gradients up to a maximum of 20%. And you can have here separate vehicles both for either mucking out and also for supplying the machines with consumables. On the right-hand side, you see a typical truck to take the muck out. Here you need in the tunnel the turning tables to follow the drive direction. You're more flexible with so-called multi-service vehicles. It's also for safety reasons. They have 2 driver cabins on each side of the vehicle. And so this is more and more a common solution. Such a multi-service vehicle can load 1 complete set of segmental lining rings, can take quite high loads. What is also, they're quite flexible in kind of demand for operating under tight curves. If you have here a shaft layout that you can first handle the gradients that are required, but you can also drive here quite tight radii if it's required. Another possibility is that you have continuous conveyor systems that is mainly used also for long tunnel drives. The advantage is that you are completely independent from other logistical systems. You can guarantee and support a high transport capacity, and you can also have a continuous muck transportation system and can achieve quite high tunneling performances. These continuous conveyor belts, they depend on the drive. It's required to do belt extensions. Therefore, you have equipment on the backup gantry. While during the ring building phase, for example, you can do extension of the belt conveyor. You can have, dependent on the space that is available on site, you can have horizontal belt storage with up to 500 meters of storage belt. You can have the same also designed if you have less space available, a vertical storage belt. And this can be completely also in-housed to follow especially if you focus on urban area, also noise emission. Here you have, for this continuous conveyor system, you need in the tunnel itself also booster drives, especially if you have to operate for longer distance tunnels. And you have also control systems in the operator's cabin to follow the different processes of conveyor belt processing. Then at the storage yard, you can have also different systems. It's quite flexible. You can have the stagger systems if you have to transfer the muck out of a shaft. You have vertical shaft conveyors that guarantee your continuous mucking out also through the shaft area. In respect of secondary tunneling works, it's more and more common that all the tunneling projects have to be realized under a quite tight time schedule. And so it's recommended, or it's requested sometimes, to do also the surfacing of the road slab preparation, for example, or you have secondary tunneling works where you have to install in parallel the vent ductilation, the ventilation duct, and also, or if you have a twin tunnel and you need to do every 250 meters or 350 meters your cross passages, that you have to do it while you do the excavation. So here you see an example here of a twin tube road tunnel where it was demanded to do in parallel already the road deck installation to build here in the cable tunnels, and to do then also a backfill here of the invert to finish here the invert area. That requires, in that situation, also long backup structure, and it's dependent strongly also on the tunneling operation process. Here to do the invert, you have to first build the center channels for the communication lines, and to backfill here then the side area with cast in place concrete. These secondary tunneling works can quite strongly interfere with your tunneling operation itself. So it requires a quite systematic planning of the different processes like operation, like ring building time, like ventilation duct installation, but also with the delivery, for example, of the segments in sequences in the tunnel, in order here to avoid downtimes and an impact on your performance of tunneling works. Here you see, for example, the machine operating while you do the first stroke. That means while you excavate the first section, you have to also bring in already the segments that they're in place when the excavated section is finished, that you can start right away with the ring building. You have also to deliver in time your mortar in order to avoid delays on site, impacting your tunneling performances. So it's quite strong planning that you need to have at hand to support your tunneling operation. You're more flexible with the so-called independent gantry for doing all that invert works in tunneling. We developed here a gantry system that follows independently the machine itself. It follows the machine around 80 to 100 meters behind. And while you do in front the operation and ring building process, you can do about 80 to 100 meters behind the machine. You can do all works here for installation of here the culverts, and also guarantee the backfilling independently of the machine operation drive. It's a self-propelled backup gantry and can be operated in two modes. In a drive-through mode, that you can deliver the machine here with the segments, and when they passed, you can open here up the backup gantry and place with a backup structure here your culverts. There are also other secondary tunneling works. If you do marking out with a conveyor belt, you can leave then your conveyor belt in the tunnel if the tunneling works are finished, and use it in a reverse operation, that you bring from outside material in to backfill, for example, the invert, if you do it after your complete tunnel is finished. So there are methods and means that you have to look in advance to optimally adjust it to your tunneling works. Here it's also an example of the longest rail tunnel in the world, of the Gotthard Base Tunnel, that was opened for the public in June this year. During tunnel construction, here the tunnel was excavated using an open type of machine, a gripper machine, where the tunnel support consisted of anchors, wire mesh shotcrete, sometimes in quite in sections with bedrock quality, also with steel anchors. And it demanded then also some drainage mats afterwards, and also finally a cast-in-place concrete as a secondary lining. And that was done by a backup structure that also followed the operation. It had we called it the worm. It had a total length of 600 meters, and it operated in different sequences. It first here, on the first part, it disconnected all services from the tunnel sidewalls that you have, like cables, like water pipelines. Then, because they operated in rock with high convergences, they sometimes had to do a reprofiling of the tunnel sidewalls. And then they had to put in, because the tunnel had to be watertight, to avoid also mountain water in the tunnel, so they had to furnish it with membrane and drainage installation. And finally, they had on that 600-meter long backup structure also tunnel shutter to enable cast-in-place concrete works for the secondary lining. And then all the service lines had to be again installed. And so this all can be done in parallel of a machine operation drive. So that's the picture here of that 600-meter long worm from the front side and from the rear part. They also did in parallel do some cross passages construction to the parallel tunnel that was excavated with a secondary TBM. Well, that was a relatively quick overview about the tunneling site and logistics. And because I was a little bit too fast, maybe there are quite a few questions that come up now. Thank you for your attention.